Yo, good day everyone. You are welcome back to Class Bridge. Now, today we are going to be looking at another important concept in vector analysis, which is the cross product. You remember at our last video, we talked extensively on dot product. So when we talk about cross product now, what do we mean? You remember I told you that when you perform dot product, it is going to give you a value that is scalar. But when you perform a cross product, it is going to give you a value that is a vector, but not just an ordinary vector. This vector we are talking about is a vector that will be perpendicular to both of those vectors that you took their dot product. Which means if we have a vector A and we have a vector B, then we perform the cross product, it is going to give us another vector, which is vector C. This vector C is what? A vector that is perpendicular to both vector A and vector B. I hope that is clear. Very good. So, by definition, we can say, given that A and B are vectors, right? The cross product of vector A and B is another vector, say C. Another vector, say C. C is that vector that is perpendicular to both vector A and B. It's as simple as that. Now, if you look at this image here, you can see that we have two vectors, A and B, right? Now, it is telling us that when we take the cross product of vector A and B, it is going to give us another vector, which is what? C. You can see this C is forming 90 degree to A, and it is also forming 90 degree to B. So it's as simple as that. So which means that even if they should wake you up from sleep, that tell us something about cross product, you should be able to have something to what? To say. It's as simple as that. Now, the question is, how do we solve problems on cross products? How do we tackle them? It is very, very, very simple. Now, let's say we have a vector A. Let's say we have a vector A that has this component. Let's say we have A1I, right, plus A2J, can you see, plus A3K. This is one. And we have another vector B here. Another vector, which is vector B. That is what? B1I, can you see, plus B2J plus B3K. The cross product of these two vectors is given by, let's say we have A cross B, right? So we can represent them in form of matrices where we have I, we have J, and we have K. Right? Very good. Now, since A comes first, we have the components of A. I is already here, J is already here, K is already here. So we have A1, A2, and A3, right? Very good. Now for B, we will be having what? B1, B2, and B3. It's as simple as that. So If you are familiar with matrices determinants, you will not have problem. So this will be equal to I. Now the I here, we have I. This I here can be found in first row and first column. So when we cross the first row and the first column, what do we have left? We have A2, A3, B2 and B3. So we transfer them here, right? It's as simple as that. So we have A2, A2, A3 and B2, B3. It's as simple as that. Now for J, we have minus J, minus J. So where can we find J? First row and second column. First row, second column. So when we cross the first row and we cross the second column, what do we have left? We have A1, A3, B1 and B3. A1, A3, B1 and B3. So we have it here. A1, A3, B1 and B3. In the same vein, if we want to find for K now, we have plus K, right? You already know what we are going to do. We cross, where can we find K? First row, we cross it, and third column. First row, third column. What do we have? We have A1, A2, B1 and B2. We have A1, A2, B1 and B3. It's as simple as that. So now when we have 2 by 2 matrices like this, their determinant is just what? The difference of the product of their diagonal, right? The difference of the product of. So what am I saying? It means that it means that we have A cross B. It means that we have A cross B will be equal to, now we have I from here. Now from here we have I. What is the product here? A2, B3. We have A2, B3 minus A3, B2. It's as simple as that. So here we have minus J, which will be what? We have A1 times B3, A1, B3 minus A3, B1. A3, B1. It's as simple as that. Plus for K now, we have A1 times B2, A1, B2 minus A2, B1. A2, B1. It's as simple as that. A2, B1. It's as simple as that. Now, this will give us the C, which is another vector that is perpendicular to what? A cross B. So now let's pick an example. All right, so let's see this example. They told us to find the cross product of vector A, which is 2i plus 3j plus k, and B to be what? 6i plus 0j plus 3k. Very, very simple question. So let's solve this together. So we have A cross B will be equal to, so we have our unit vector here, I, J, and K. Very good. So our A component will be what? 2, 3, and 1. While our B components will be what? 6, 0, and 3. It's as simple as that. Now, which implies that we'll be having for I, when we close this section, we close this section. first row and first column, we are left with 3, 1, 0, 3. Now for J, for J, for J, we have to close the first row and the second column, right? So what do we have left? We have 2, 1, 6, and 3 left. Very good. Now for K, we have to close the first row and the third column. So what do we have left? We have 2, 3, and 6, 0. It's as simple as that. Now we know what to do next, right? So A cross B will be equal to, we have I into, we multiply this, 3 times 3, that will give us 9, minus 1 times 0 is 0, minus J, 2 times 3, that is 6, minus 6 times 1, that is also 6, right? Plus we have K, 2 times 0, 0, minus 6 times 3, that is 18. Fine. So here we are having our A cross B to be equals to 9 minus 0, that is 9I, minus 6 minus 6, that is 0. So we have minus J, minus 0J, plus 0 minus 18, that is minus 18. So we have K into bracket minus 18. And here we have our A cross B to be equals to 9I minus 0J minus 18K. It's as simple as that. So this here is giving us another vector, you can see, which we can call C, vector C, right? So which means that this vector C here is perpendicular to what? Vector A and vector B. It's as simple as that. Now remember in dot product, we said that when two vectors are perpendicular to each other, what is going to happen? Can you remind me? We said their dot product will be what? 0. And we have just said that this vector C that we have here is perpendicular to A and it is also perpendicular to B. The implication is that if I should take the dot product of A and C, it must give me 0. That is the implication. So let's confirm if that is actually true. So we have A, we have a vector A to be what? 2I plus 3J plus K. And we have a vector C now to be equal to 9I minus 0J minus 18K. If you are very, very smart mathematically, you can see this is correct. I'm already seeing the answer. Now, what does it imply? Remember in dot products we say we multiply components wise, where this multiply this one we also multiply its component, also K we multiply its component, where I times I is 1, J times J is 1, and K times K is 1. So let's take the dot product of A and C and confirm if our answer will actually be 0 truly. So we have A dot C So we'll be having what? 2 times 9, right? I squared plus 3 times minus 0 j squared plus 1 times minus 18 plus k squared, right? So which means that my a dot c will give me 2 times 9 is what? 18, and I square is 1, right? Plus 3 times 0 is 0, j square is what? 1, 1 times 0 is still 0, plus 1 times minus 18 is minus 18, k squared is 1, right? So we have minus 18. So what do you see? A dot c will give you what? 18 minus 18, which is equals to 0. It is correct. Now you can check for b dot c and confirm if it is actually going to give you 0.